So today we are going with a new topic, like a whole new topic in our mathematics, understanding analysis. We can say this course also as an introduction to analysis. This is my new range of topic. I'm still making videos on linear algebra, but this is a different topic I really want to go with. So in this topic, we will follow the book named Understanding Analysis by Stephen Abbott. So in this book, our first chapter name is The Real Number. The first chapter name is The Real Number. We have six subsections in this book. First subsection is discussion, in which we will discuss about the irrationality of root 2. Second is some preliminaries. Third is the axioms of completeness. The fourth one is consequences of completeness. The fifth is Cantor's theorem. The sixth is epilogue. We'll go with all subsections in each video. In this first video, I will go with the first subsection, the discussion, the irrationality of root 2. As we know, there are lots of different numbers, real numbers, natural number, whole number, rational numbers, irrational numbers. So, real number consists of all the numbers minus 1, minus 2, 1 by 2, 0, and everything. Then we have a whole number. We have integers. Assume you know all this basic knowledge before. We have rational numbers and we have irrational numbers. So here we will prove the irrationality of a root 2. So going with the theorem 1.1, 1.1.1, there is no rational number whose square is 2. This is the theorem. Do we have any rational number whose square is 2? Rational number should be in the form of p by q, and q should not be equal to 0. No. But we have an irrational number whose square is 2. Which irrational number it is? It's root 2. When we do the square of root 2, we'll get the answer 2. So we have to prove that there is no rational number whose square is 2. As we know, a rational number is any number that can be expressed in the form p by q, where p and q are integers. This is also. So do we have any option that when we do the square of any p by q square, not 2? No. So we will prove this by the proof by contradiction. So for the proof, then in a very good way. So let assume there is a rational number whose square is 2. So if it's a rational number, so we can write it in the form of P by Q, where Q should not be equal to 0 and PQ belongs to the integers, right? So now we have P by Q is equal to 2. P by Q. No. Now we have P by Q. So what we assume that our square is 2. When we do the square of this 2, we will get 2. It will be P square by Q square is equal to 2. We will get P square is equal to 2Q square. Means 2 divide P square, because P square is equal to the multiple of 2. So we can say that 2 can divide P square. 2 can divide P square, 2 can divide P2, right? Go with with the multiple of 2. If we multiply by 2 on this side, uh, 2 divides P square. For sure, 4 divides P square 2, because it's a multiple of 2. So here we can go 4 divides 2Q square. It's an equal. So 2 divides Q square. Then 2 divides Q. And from this, like we know 2 divides P and 2 divides Q. So they have a common factor 2. So P and Q can be equal to 2, which can't be possible. So by this theorem, by the proof of contradiction, we can say that we can say this: there is no rational number whose square is 2. Okay, I got with this. So this is this one. Now we will go with the natural number. What are natural numbers? Starting from 1, 2, 3, 4 up to the infinity, there are natural numbers. Natural numbers, we have a different set of numbers too. They're known as integers. They are starting from minus infinity to plus infinity. So can we say that natural number is a subset of two integers? This is integer. Yeah, we can say that. For this, we have the rational numbers denoted as Q. So rational number that should be in the form of P by Q, where Q should not be equal to 0, and P and Q belongs with an integer. Right? This is the main thing here. Other than that, we can say, so this is the chain. Natural number is a subset of integers, and integer is a subset of rational numbers. This is the whole chain we can say. So in this first section, this is the basic things we have to know: the irrationality of root 2 and what sets of numbers we have. So in this video is up to